This is lesson 6-2 from the Algebra Readiness textbook. For today's lesson, you'll want your notes packet, a calculator, and a sharpened pencil. Work the 2 study guide problems and then continue when you're ready. For this first one, you should write the given information as a ratio, 10 quarts over 1 minute. I want to convert that rate to gallons per hour. That means that I'm going to need 2 conversion factors. One to get from quarts to gallons, and another to get from minutes to hours. Let's start with quarts to gallons. I know that there are 4 quarts in 1 gallon. I will strategically place quarts in a position so that they are diagonal, or one in the numerator, one in the denominator, which causes the labels to cancel out. And then on top of it, I put 1 gallon. In the next one, I need to use the next conversion factor where my minutes cross out. Well, I know that there are 60 minutes in 1 hour. I know that minutes is in my denominator, so I will put 60 minutes in the numerator and 1 hour in the denominator. Then we simply multiply across. 600 gallons is all that's left in the numerator, and 4 hours is all that's left in the denominator. 600 divided by 4 is 150 gallons per hour. Okay? The next one, David has a board that is 12 feet long. Dennis has a board that is 150 inches long. Whose board is longer? Well, it's really difficult to compare when they are not in exactly the same unit of measure. So let's convert one of them to the other unit. So I'm going to convert 150 inches. Now, you might have chosen to go the other way. 150 over 1, and I'm going to multiply it by a conversion factor in which 12 inches is equal to 1 foot. Notice that inches cancel out, and I'm left with 150 over 12 feet. Then I have to simplify. 150 divided by 12 gives me 12 and a half. So the question says, whose board is longer? Well, I see that Dennis has a 12 and a half foot board, and David's board is only 12 feet. So whose is longer? Dennis. Because 12.5 feet is greater than 12 feet. Today's learning target is to write and solve proportions. Now, a proportion, you might recall, is when you have 2 ratios that are equal to each other. In this case, 6/9 and 8/12 are equivalent ratios. There's a couple ways that we're going to learn about to decide if they are equal ratios. So how do you know if it's a proportion? Well, let me show you. One way is that you could simplify both of these ratios and the simplest form would be the same. In this case, I would divide both of these by 3 over 3, and this one equals 2/3. Then for this one, I could divide both the numerator and the denominator by 4 over 4, and I get 2/3. 2/3 is equal to 2/3, so therefore the proportions are equal. So one way is to check their simplest form. The second way to check if 2 ratios form a proportion is to see if their cross products are equal. So what are cross products? That's when you multiply diagonally. 9 times 8 is 72. 12 times 6 is 72. This becomes really fast when you have a calculator, doesn't it? So do you see how they make a cross? That's where the word cross product means to multiply, that's where it came from. So when cross products are equal, then you have unequal ratios. So make sure you have this written down in their notes. Are the cross products equal? So let's write a definition for cross products. Cross products, in a proportion, cross products are equal. And then maybe throw this one down as your example. Some people write it out as 6 times 12 equals 9 times 8. 72 equals 72. Okay? Moving on. The first part of what you're expected to do today is to be able to tell me if two ratios form a proportion, or are they equal to each other? So how do you know? You can either state that they have the same simplest form or that their cross products are equal. So try these two and come back when you're ready to compare your answer to mine. For the first one, the cross products would be 14 times 4 and 6 times 10. 14 times 4 is 56. 56 does not equal 60. So do they form a proportion? No, because 56 is not equal to 60. Or you could say cross products are not equal. Okay, how about the ratios 2 to 6 and 3 to 18? Many of you probably switch these to fraction form, 2 to 6 and 3 to 18. Now, 6 times 3 and 2 times 18. 6 times 3 is 18, and 18 times 2 is 36. That's clearly not equal. So are they a proportion? No, because 18 does not equal 36, or cross products are not equal. All right, try these three. Pause the video, try them, come on back to compare. All right, for the first one, you should have gotten yes, because cross products are equal. They're 36. Then the next one, 20 times 5 is 100. 15 times 7 is 105. So no, because cross products are not equal. Then this one, 7 times 30 is 210. And then 17 and a half times 12 is 262 and 5/10. So no, these two ratios do not form a proportion because cross products are not equal. Okay? All right, moving on. Let's try these next three. Actually, I feel like we're going to skip those. Let's move on. Let's work on solving a proportion. Now think about this. If you were trying to solve a proportion, let's say this one right here, and I gave you 6 to 9 equals 4 to 6. Now, if you know that cross products are equal, so, okay, hold on. Let's say the 4 was missing, but you do know that the cross products are equal. 6 times 6 is 36, right? So what number would you have to put in this blank so that 9 times that would also give me 36? 9 times what equals 36? It has to be 4. So the fact that cross products are equal makes us useful for when we want to solve a proportion for a missing number. In 6th grade, you learned that a fraction is a type of a ratio. You use two methods to find a missing value. The first method was using equivalent fractions, using the scale factor. So 2 to 7 equals x over 28. You said, okay, I can multiply this by 4 over 4, and I get 28, so this would be 8. So you used equivalent fractions. See that? So x equaled 8. Another way that you learned was the unit rate, where you simplified and then found the equivalent fraction. So instead you said, oh, 7/14 is 1/2. So 1/2 is 4/8. So x equals 4. Okay? These are all very good ideas. Now today we're going to focus on the cross products. You are welcome to use any of those other methods you've already mastered, but in 7th grade, the standard specifically says students will know that two ratios form a proportion when their cross products are equal and can use cross products to solve proportions. So I'm not saying forget about what you learned in 6th grade. I'm saying we're going to add on to it. Sometimes those other two methods are not going to work. Cross products are always equal in a proportion, and cross products would work on any of those two previous examples as well. Take a look here. 6 times 12 is 72. So I know that 9 times some number must also equal 72. So what must x be? X must be 8, because 9 times 8 is 72. Now you could have written it like this. 12 times 6 equals 9 times x, right? 9 times x, 12 times 6. 72 equals 9x. Then you divide both sides by 9, and x equals 8. Okay? Let's practice a little. X to 9. Now, don't be afraid to rewrite these that are written with a colon. X over 9 equals 4/6. Remember that cross products are equal, so 9 times 4 is the same as whatever number times 6. So what's my missing number? 9 times 4 equals 6 times x. 9 times 4 is 36. 6 times x is also 36. Some of you already, without showing any more work than what's above my squiggly line, know what that answer is. And know the answer is 4. Oh, not 4. Good grief. I meant 6. There we go. 6 times 6 is 36. Others of you prefer the equation method, which I have below, where it's actually writing out more of the work for you. X equals 6. Either method is okay. Okay, for now I would like you to pause the video and work these 4 examples. Solve the proportion, and then come back to compare your answers to mine. Okay, now that you're back, I hope that some of you were able to see that, holy cow, I can just take 9 times 2, divide it by the 3, and it tells me what h is. Some of you probably got there pretty quickly, because 9 times 2 is 18, and so 18 divided by 3 gives me 6. The next one, 4 times 55 is 220. So that means 5 times some number is 220. So I need to divide 220 divided by 5. And you got 44. The next one, 22 times 21 is 462. So D times 6 equals 462. So I get 77. And lastly, 7 8/10 times 13 gives me 101 4/10. And so 6 times some number gives me the same amount, and I get 16 9/10. Okay? Now, the next thing we have to be able to do is set up the original proportion. So, to make lemonade, Mitch needs 6 lemons and 8 cups of ice water. How many lemons do you need if you have 24 cups of water? The easiest way to do this is to look at the labels on your numbers. 6 lemons, 8 cups of water. What am I talking about? Lemons and water. or cups of water. Okay, so when you're writing a proportion, it's two equal ratios. So here I have two lines for my ratios and an equal sign between them because they're equal to each other. The first ratio is the given scenario. Mitch needs 6 lemons. Lemons goes in the top, see that? And 8 cups of water. Now, if you want that to taste exactly the same, and you have 24 cups of water, notice water stays in the denominator just like it says here. Water will be here. Water, water. Then how many lemons, I'll make that a cursive L, how many lemons do you need if you want it to taste the same? So it's an equivalent ratio. Now solve it using cross products. So 6 times 24, and go ahead, get your calculator fired up, or do that one in your head. And you get 144. And that means 8 times some number, 8 times L equals 144. So you divide by 8, and you get 18, and then make sure you're always labeling when you have a word problem. 18 lemons. In the next one, 3 posters cost $9.60. At that rate, how many One Direction posters can Aaron buy for $48? Okay, well, what are my labels on my numbers? Well, on this number, I see it's dollars, and I want to know how many posters. Here it was 3 posters. See that? So posters, okay, money and posters. Okay, so let's write our proportion. There's for my first ratio. The ratios are equal to each other. That's what a proportion is, 2 equal ratios. The first ratio is right here. 3 posters for $9.60. I see that posters is right here. Now you might have flipped that around, and that's fine. You'll get the same answer. And then money goes in the top for the way I have it set up, so $9.60. At that rate, how many posters can she buy for $48? So I'm going to put $48 up here, and how many posters? We'll call that P. Now go ahead and solve using cross products. And you get 15 posters. Okay, let's get a little more practice setting up these proportions. Let's try the next 2 in your packets on your own independently, and then come on back when you're ready to compare your answers to mine. For this one, Sydney buys 3 cans of dog food for 99 cents. So cans is going to go in the numerator, and money is going to go in the denominator. So we're going to write our proportion. The first proportion is 3 cans for 99 cents. My second ratio in the proportion will address how much will 15 cans cost. Make sure to put 15 in the numerator because cans has to be consistent across your ratios. And I want to know the cost. Now, some of you like to look at this and go 3 times 5 is 15, so 99 cents times 5 will give me an equivalent fraction of $4.95, and that is just fine. However, or if you used cross products, you'll get the same answer. And the iPhone problem. An iPhone microchip inspector found 3 defective chips in a batch containing 750 good chips. So, defective chips in all chips. That's my ratio. Now we're going to write a proportion. So defective were 3, and there were 750 in that batch. At that rate, how many defective chips can we expect in 10,000 chips? Okay. Now, this kind of math is done often when they want to figure out, when big companies want to figure out the warranty and how much it's going to cost them to insure a product based on how many are expected to be defective. So we're going to take cross products and do 10,000 times 3, and then divide it by 750, and you get 40. They're expecting 40 of their iPhones to be defective. Okay? All right, so with that, you get to do 6-2. It is on page 292, 5 through 12.